Hello students, this is your favorite math professor, Professor Amlin, and today we are going to be studying section 5.5 of your statistics course. And in this section, we are actually going to go back to the last chapter, to chapter 4. And in chapter 4, we learned something called binomial distributions. And in that chapter, you learned how to use a button called Binom PDF, and you used that button to fill out a chart, and we had X and we had P of X. Let's say like 0, 1, 2, 3, and these were decimals over here. And when you wanted to find the probability of 3 or fewer, you added this plus this plus this plus this decimal. If you wanted the probability of 1 or more, you took this decimal, and this decimal, and you added them together. And that is a review of last chapter. Now, how does that compare with what we're going to do in this chapter? Before we continue, if you have not already done so, I want you to stop and pause this video. I want you to go to My Math Lab. I want you to go to the button Course Tools. Then I want you to click on the button called Document Sharing. And I want you to print section 5.5 so that you can follow along with me. Please do that now if you have not already done so. I've logged in and I've noticed that a lot of you are not printing this document. So if you are having difficulty with this, could you please email me and let me know? I really would like you to print these and do them along with me as I do them on this video. So if you have not done so, please go do this right now and then come back and we'll do section 5.5 together. Here we go. All right. Approximating a binomial distribution. In section 4.2, last chapter, you learned how to find binomial probabilities, and that's when we used our Binom PDF. For instance, consider a surgical procedure that has an 85% chance of success. That was your P last chapter. When a doctor performs this surgery on 10 patients, that was your N, you can use the binomial formula to find the probability of exactly 2, and that was our X. So what we did last chapter is we typed in Binom PDF, N was 10, P was 0.85, and X was 2, and that's how you got your answer. But what if the doctor performs the surgical procedure on 150 patients? Oh my goodness. So what would that look like? That would look like X, P of X, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 150. Do you ever really want to fill in a chart that big? Heck no. And then it says, find the probability of fewer than 100. So what you would do is when you got to the 100, then you would have to add up all these decimals all the way up to the 100 to get your answer. Very time consuming, very tedious, not efficient. So what we're going to do is we're going to learn a new method so that you don't have to add up all 100 of these decimals. Here we go. To do this using the techniques described in 4.2, you would have to use the binomial formula 100 times. You would have to do Binom PDF 100 times on your calculator. Then, after you found all those decimals, then you'd have to add them all up and find the sum of the resulting probabilities. This approach is not practical, of course. A better approach is to use a normal distribution to approximate the binomial distribution. But in order to do that, there's a lot of steps. So what I've done in this packet, I've broken the steps down, and then at the end of the packet, we're going to put them all together. So here we go. Let's start with breaking it down. The first thing you have to do these problems, in order to use a normal distribution to approximate a binomial distribution, two criteria must be met. If one or both criteria are not met, then the problem cannot be completed. The first two criteria are NP has to be greater than or equal to 5, and NQ has to be greater than 5. If these both are met, if you can check off both, if both criteria are met or satisfied, then the mean and the standard deviation is mu equals NP, and standard deviation is the square root of NPQ. So let's do a problem. 3 binomial experiments are listed below. A and then B and C are on the next page. Determine whether you can use a normal distribution to approximate the distribution X, the number of people who reply yes. If you can, find the mean and standard deviation. If not, explain why. In a survey of heavy media users in the United States, ages 8 to 18, 47% said they get fair or poor grades, see and below. You randomly select 45 heavy media users in the United States, ages 8 to 18, and ask them whether they get fair or poor grades. So here we go. Let's see if our criteria are met. The first criteria is NP greater than or equal to 5, and NQ greater than or equal to 5. N is our total number of people in our sample size, which is 45, times P. P is our probability, our percent, so that's going to be times 0.47, greater than or equal to 5. Pick up your calculator. Here we go. 45 times 0.47 is 21.15. Is 21.15 greater than or equal to 5? Yes, so far we can do the problem. Now let's check this criteria. N again is 45. Now, how do we find Q? We learned this last chapter. Q is equal to 1 minus P. Well, we know P is 0.47, so 1 minus 0.47 is 0.53, so times 0.53, greater than or equal to 5. Here's my calculator, so I'm going to do 45 times 0.53 is 23.85. Is 23.85 greater than or equal to 5? Yes, it is. Therefore, we can do the problem. If you can do both, if both of these criteria are met, then the mean is equal to NP. Well, you just found NP right here above. NP you found to be 21.15, so you don't even have to do any math on that one. The standard deviation is equal to the square root of NPQ. This one you have to do. This is going to be the square root of N is 45, P is the 0.47, and the Q is the 0.53. Put that in your calculator. Excuse me. Put that in your calculator. Square root of 45 times 0.47 times 0.53. Can everybody see that, I hope? Hit enter, and if we round that to 2 decimals, we get 3.35, and there's our answer to example 1. Here we go. Let's do another one. Letter B. In a survey of light media users in the United States, ages 8 to 18, 23% said they get fair or poor grades, see and below. You randomly select 20 light media users in the United States, ages 8 to 18, and ask them whether they get fair or poor grades. So let's do our criteria. NP greater than or equal to 5, NQ greater than or equal to 5. In this case, N is 20. P is our percent, our probability is 0.23, greater than or equal to 5. Pick up your calculator. 20 times 0.23 is 4.6. Is 4.6 greater than or equal to 5? No, it is not, so the problem can't be done. Why? Because NP is not greater than or equal to 5, so you can't do the problem. If either of these is not bigger than 5, then the problem is done. Let's try letter C. In a survey of adults in the United States, 29% said they have seen a person using a mobile device walk in front of a moving vehicle without looking. You randomly select 100 adults. There's your sample size. There's your N in the United States, and ask them whether they have seen a person using a mobile device walk in front of a moving vehicle without looking. Let's do it. NP greater than or equal to 5. NQ greater than or equal to 5. In this case, our N is 100. P is our percent, which is 0.29, greater than or equal to 5. If you type in 100 times 0.29, you get 29 greater than or equal to 5. So yes, we can keep going. Check. That side's good. N is 100. Q now, how do I find Q? Q equals 1 minus P. So P was 0.29. 1 minus 0.29 is 0.71. So 0.71 greater than or equal to 5. I'm sorry. 100 times 0.71 is 71 greater than or equal to 5. Yes, it is. Once you've verified that both of these numbers are bigger than 5, then the mean is equal to NP, but you already found NP right above, which is 29. And sigma equals the square root of NPQ. N is 100. P is 0.29. Q is 0.71. Type that into your calculator. You do second square root, 100 times 0.29 times 0.71. Hit enter, round that to 2 decimal places, 4.54. 4.54. And at this point, I'm going to stop and start the next video. Give me just a second, and I'll see you soon.